So in the analysis of the circuit, we start by analyzing the meshes. We first identify mesh 1, mesh 2, mesh 3, and mesh 4. And we can quickly see that mesh 4 has a current of 2 amperes, and mesh 1 has a current of 5 IY as well. We can also see that the M4, mesh 4, the current is in a counterclockwise direction, while all of the other ones are in the clockwise direction. We continue to do the KVL for mesh 1, 2, 3, and 4. For mesh 1, as you can see, we find the 14 resistor. We multiply that by I1. Same thing for the 21 resistor, I1 minus I2 as it is in the middle of two meshes. And then we plug in I1, which as stated before is 5 IY. We continue this process for mesh 2, mesh 3, and mesh 4. And we were also able to find I2 very quickly because of the equation left out. When we do systems of equations, we also find I3, and then we're pretty much set to do the equations. For the voltage in Vx, it's fairly simple. As we already know, it's 15 times I2 due to Ohm's law. So we do 15 times our I2 current, which we already have, and we get Vx. Now we want to find Iy, which we know we have to do I2 plus I4, as both the currents are with each other, one's in clockwise and the other is in a counterclockwise direction. So we have to add them. Once we do that, which you can see here, we get our Iy, which is 0.714 microamperes or 715 milliamperes. And that is all.
Okay, so here we're going to assemble our circuit. Here we have first what is going to be the resistors. We have a 15 ohm resistor over here in the top right. We have a 14 ohm resistor in the top left, and they are connected. And then we have a 17 ohm resistor here. Then we have a wire that goes here. And now we have a 53 ohm resistor over here. We have a 21 ohm resistor over here. Then we have a 20 ohm resistor over here. Now I'm going to input first the dependent sources. First we will go with what is the current dependent current source. We're going to input it here. And it's going to have a small wire connecting this. Now we also have here, this will connect. Oh, here we have a voltage source that is of 5 volts, and that is directly connected to this resistor. Perfect. Now we also have a current source over here that is of 2 amperes. And then we have here just a string. And we will connect the negative of the output of the dependent source here. We'll connect the positive also, the other way around. And now we will connect them with wire. As such. And we will get another little wire over here, connected here. Now that is perfect. Now we will connect this 21 ohm resistor and connect it to the other part of the circuit. And now we will have this resistance here. And now we're moving on. We will connect the voltage dependent voltage source. And we will connect this coming in through the positive and leaving from the negative. So here, as you can see, we will put wire. here and here. Now we will connect the voltage to what is our Vx. So we will connect it with the B to this end and with the A to this end. As para el otro. Okay, so now we have our final circuit. And as we can see here, what would be the Vx? It has a voltage of 19.28. And what would be the IY, the current we're trying to find, would be 714 microamperes. And this is our circuit for the first question.
So I'm going to explain how to solve the second exercise. As we can notice here, we defined our nodes as node 1, node 2, node 3, node 4, and node 5. You can define them as you want. We did this by convenience, and we also define our ground here. We recommend to define the ground in the place where you have the more sources. As we can see here, we have 3 sources. So we define these as our ground. The first thing we can see here is that between node 1 and node 2, we have a supernode. So we have to do the supernode equation, which is going to be B1 minus B2 equals 16. We define our signs because the plus and minus are going on the direction of B1 and B2. So here we are going to have our first equation. Then we have our free equation, which is going to be the node 3 is equal to minus 8. This happens because we don't have any resistance that would change the voltage here. So we can say that it's going to be the same voltage, and it's negative because we have the minus sign on the same direction as B3. So we have here our second equation. Then we have here something like that it's kind of the same thing, but we have a dependent source. We have 4ix. So we can define ix equals B4 minus B5 divided into 6k. This is going to be very important because we are going to use it in the future. And we defined it because B4 is traveling to B5, so we can put B4 minus B5, and it's going to be passing through the 6k resistance. So we divide it into 6k. So now that we have our equations, we can start analyzing node 4. As we can see, node 4, it's traveling to node 5, so we can put B4 minus B5 and divide it by 6k. Then we can put B4 minus 0, which is ground, and divide it by 3k. Remember, you put 0 when it's ground. And then you have B4 minus B1 divided into 2k. This is only the factorized, so it's easier to plug in the calculator later. Now we are going to analyze node 5, which is this one. And we do the same thing. Node 5 minus B4 divided by 6k. Then it's B5 minus B3 divided by 8k. And then we are going to consider this as our output. And then we are going to consider the minus 1 milliampere as our input. This is going to be really important because we have to put in one side the input, and in the other side we have to put the output. And this is going to be our equation. Then we have to define B2 in terms of what we can understand in the variables that we can know, which is voltages. We have to have everything in voltages. So we can define B2 as 4ix. So it's going to be like this. Now that we have all our equations, we can plug it in the calculator. We are going to plug in this one, not this one, because it's in terms of ix, and we need it in terms of voltage. So we are going to put this one, and this one. And as we can see, we have 5 unknowns and we have 5 equations. So we can put it here on the matrix, and we obtain that B1 is equal to 16 volts. B2 is almost 0 volts with 3 times 10 to the minus 3. Then B4, it's equal to 7.58 volts. And then we have B5 equal to minus 2.52 volts. And here we have our free equations, which is going to be B3 is equal to minus 8 volts. And the last thing we need to do, as I mentioned before, and as we defined it before, Ix, it's going to be equal B4 minus B5. and divide it by 6K. So now that we know our values, we have to plug in here, and we would have that Ix is going to be 1.68 times 10 to the minus 3 amperes. And this would be the second problem.
Hi, my name is Eduardo Ochoa, and today we're going to be solving the following circuit, which is right here. This is the second circuit, and we're going to be using the simulator to see if the calculations that we made by hand are correct or if they are incorrect. So let's start with the solution. Here we have a couple of resistances. We have 1, 2, 3, 4, 5 resistances, right? So we have this 2 kilo ohm, which is this one right here. We have this 3 kilo ohm going right here, 6 kilo ohm at the bottom, 2 kilo ohm at the top, and 8 kilo ohm right here to the right. Then we're going to connect these using wires, and we have a 16 volt voltage source here, the 8 volt voltage source down at the horizontal. Upward on the middle of the circuit, we have a current source of 1 milliampere. From here, we're going to have ground, since this is the node with the most sources, and that is how we used in the calculation as well. And finally, we have this voltage source that depends on current. So it's a current controlling voltage source. And we're going to connect it as well. Wait, this cable needs to disappear. So it is, which cable is it? It's this one. And we can run it. And all of the components are found here on the draw. So we have the wires, which are these, the parts of the circuit that don't have any component, the resistors. And for the inputs, we have ground, which, as we stated, was going out of the middle node. We have the voltage source, which were 2, and it's very important that you mind this, the sense of the volts or the voltage source, since here both are with the positive facing the left side. So it's important that you note that, and that is determined by how you insert them into the circuit. Then we also have the current source, which is down here, the current source, which is 1 milliampere, and finally for the dependent voltage source, we find that in active building blocks, and it's down here as current controlled voltage source, right? Because it's a voltage source that is being controlled by current. And as we can see right here, this, I might be missing some things. Here it's very important that we have the correct values, right, of the side, because if not, well, our simulation is going to be completely inaccurate. Here we have 1 milliampere. Up here at top, we have 2 kilo ohms. Down here, we have 8 kilo ohms. Down here, we have 6. Above it, we have 3. Right here. Then, perpendicular to that, we have a 2 kilo ohm resistance, and this is a 16 volt source, and this is an 8 volt source, right? 8, 16, 2, 3, 6, 8, 2, 1, and this, well, since it's 4, we have the 4 right there. And, well, like that, we can verify we were looking for this Ix value, and we can very easily see right here, we have it's going to pop up right here, the answer, and the value of the current is 1.68, which closely resembles what we calculated theoretically and proves that our calculations were correct. So that is it for the solution of this circuit, of the second circuit.